Giorgio, with your permission, shall we start?
If
Yeah.
you want, we can start.
Yeah. Thank you. We are yet to receive many participants soon. I hope everybody will join. And first of all, thank you everybody for joining this event. Today, keynote lecture will be delivered by Giorgio Pezzetti on field monitoring in geomechanics for TC220. We have a chair, TC220, Andrew Ridley with us. And unfortunately, some of the IGS Indian chapter eminents are traveling here and there. They could not join, but they have conveyed best regards to Giorgio. And this, without further delay, I would like to briefly introduce Giorgio for your information. He is well-known, eminent person across the globe. So Giorgio is born in 1954. He graduated from Politecnico di Milano University in 1979 with a degree in civil engineering. In 1980, he joined the structural division of ISMES, best known for Experimental Institute for Models and Structures, as an applied research institute belonging to INA, the largest power company in Italy. He was in charge of laboratory and institute test and structures. In 1982, he joined the Geotechnical Instrumentation and Investigation Department, where he focused on instrumentation and monitoring technology, large-scale test, and long-term performance of geostructures. He was involved in a broad spectrum of relevant and challenging instrumentation projects in Italy and worldwide, such as the stabilization of the Tower of Pisa, the remedial work and monitoring following the disastrous landslide at Valpola in Vettelina, Italy, the design of the monitoring system for Acereta Dam in Argentina, as well as many other significant projects. In 1996, he was appointed as head of the Geo-Environmental Monitoring Unit at ISMES. In 2000, he was one of the founder of Field SRL, a service company specializes in geotechnical and structural instrumentation and monitoring services. Since then, he has been involved in a wide range of monitoring projects worldwide, including dams, embankments, tunnels, underground structures. He has acquired extensive experience and expertise on instrumentation and monitoring of dams, slopes, tunnel, foundations, and earth structures, as well as many soil structure interaction cases. In 1995, he was responsible for organizing the 4th International FMGM Symposium, that is Field Measurements in Geomechanics, which was held in Bergamo, Italy. Since then, he has served as a permanent member of the FMGM International Advisory Committee. He has published more technical papers and has held specialized courses, lectures, and workshops both in Italy and abroad on the topic related to geotechnical and structural instrumentation and monitoring. He has been appointed by World Bank as a consultant for the upgradation of the monitoring system of Tarbela Dam, Pakistan, and is now consulting for the monitoring system of the Rogun Dam in Tajikistan, the world's highest earth dam. He is a co-director of ICGSM International Course on Geotechnical and Structural Monitoring, started by John Duncliffe and Paul Majanti. He is currently a member of ISO CEN TC182, Geotechnical Investigation and Testing, dealing with the drafting of international standards and measurement and monitoring of geotechnical application. He is presently a co-chair of ISSMG TC220, Field Monitoring in Geomechanics. In his activity, he always aimed at giving monitoring a recognized role and promoted the introduction of common rules and guidelines to facilitate the approach and the common understanding. There are much to be added to his profile, and with this short brief, I request Giorgio Pezzetti to proceed for the lecture. And prior to that, I request Andrew Ridley to have a few words about his encounter with Giorgio Pezzetti, or if you want to say something. Over to you, Dr. Andrew.
Well, thank you very much. I have to say it's an honor to be here and listen to Giorgio. I've known Giorgio for a long time now, and there's nobody better to be giving a talk of this nature. I really look forward to it. And his presence on the TC220 alongside me has been very comforting, very reassuring. So I won't say any more. I might come back at the end and just give a few notices about the TC220, but I will hand over to Giorgio and look forward to what he has to say. Thank you.
Okay, thank you, Ramu, for your presentation. Thank you, Andrew, for your words regarding me, and thank you to everybody who is attending this presentation. The idea of, sorry, let me start sharing the screen. This one. Please confirm you're looking at my screen.
Yes, we can see it, Giorgio.
Okay. So the idea of this presentation, the title is Looking at Data, from Measured Data to Presented Data, Uncertainties, Boundary Conditions, Error, and Data Validation, came to my mind some weeks ago when I attended the presentation from Dr. Balakumar, which was a very interesting presentation. I had the honor of introducing this lecture, and listening to Dr. Balakumar words, it came to my mind an experience I had some years ago, which I want to share with you because it's quite interesting to understand one key point in monitoring. Too many times we are focused on the instrument itself, on how to install, how to connect, how to read data, and so on. But not so often we are focused on the meaning of data, or better, we are trying to understand what is going on in the structure we are monitoring by analyzing data. But not so often we are able, or we do want to go into data in order to understand what really they mean. So I had this experience some years ago I want to share with you. And I hope it could be useful just to trigger in your mind something related to the need of analyzing data in detail. Okay. It is the experience was in Kuwait almost 15 years ago. Let me check. Okay. Here is the area where we had to work in Kuwait City. This is the Gulf area, and is here. And it includes the construction of a new building, high-rise building, founded on piles. You see here a couple of pictures during the construction. And this is the building after construction, completed building. You see, it is a quite slender building. So the designer asked to monitor the foundation of this building on piles in order to understand if the design hypothesis of distribution of the loads into the piles were correct. So in the foundation, they selected a number of piles, 10 piles out of 83, the total number of piles, to be instrumented in order to measure the load transferred by the building to the foundation. The piles were approximately 45 meters deep. The diameter was 1.2 meters. And the request was to install a 6 section of strain gauges, 4 strain gauges each section, at different depth in order to measure the distribution of the load. Strain gauges, the classical strain gauges with vibrating wire sensor have been installed on the cages, and they provided for the value of the strain into the pile to be transformed into load. A automatic data acquisition system was installed in order to measure both during the construction and after construction. Was an automatic data acquisition unit based on data logger. Here you see some details. This is the computer connected to the unit and so on. And here are two details which seems not to be so critical, but they are. You see that the data logger or the data acquisition unit has a grounding cable, and the grounding cable is connected to a ground element here. Okay. This is what we got when we downloaded the first set of data from the data logger. What to say in front of something like this? The client immediately said, oh, your system is not working, it's rubbish. We cannot do anything with this data. And he was right from a certain point of view. But we thought that it was not completely right. Because we started looking into this data in order to understand if it was possible to get some information from this mass of signals, which seems to be completely random. Okay, so we tried to understand what was going on. We selected some piles, and here I show you an example. This is pile number 27, I guess. And this is what we got as monitoring results. You see here the date is approximately from mid-September to end of March, let's say 5-6 months of measurement. We looked at this data, and as you can imagine, the first point we got is that there is an initial part of measurement with some certain behavior, and then another one. Of course, we checked the numbers data. Here are the numbers. The gauges were vibrating wire strain gauges, so the value we were collecting were the frequency or the digit. It depends what you use. Frequency here is a typical table of data, and we analyzed very quickly this data, calculating the minimum, maximum, and average value. And you see here it was a large quantity of data out of the normal range. So the idea was to filter this data in order to eliminate those values which were out of the reasonable value. And this was the first result. If you remember the previous picture was a completely up and down of values. Here, you see. After the first filtering, we obtained this. And that's encouraged to go on in the analysis in order to see if after filtering something was really present as information inside data. So we went on the analysis, taking the result. And if you see here, there is one interesting point to consider, that apart of this first part of the measurement, which is completely, I would say, unreasonable, from a certain date, we can detect different values for different instruments, different strain gauges, which means that we were measuring something. And each instrument was providing for a value which could have been a real value, because being inside a pile from the top to the bottom, the load is reducing, or should reduce, of course, because these are skin friction piles. Sorry, I forgot to mention. The load is reducing, and so is correct that we start from a higher value and go down to a lower. So again, looking into the data, trying to take out what is embedded into data, even if at the beginning it seems to be a completely mess, we realized that we were measuring something. And so we proceeded with this analysis. And as you see, at the beginning, we had this quite unstable part of values, and then stable. Why this? Why were this? Because if you remember the two pictures I showed regarding the grounding or earthing system of the data logger, we realized that the connection of the data logger to the earthing or grounding, I don't remember the correct English name, sorry, was not good enough. Or better, the area where we installed the ground stick was a very disturbed area because they were building the building. And so there are a lot of machinery working there and a lot of machinery connected to the same power line. And this created this disturbance. When we realized this, we disconnected the ground system and we obtained something better. But there was even another point that we realized. This is the same graph as before, same as this, just changing the horizontal scale. And you see this fluctuation, this sinusoidal trend of data before reaching the stability when we disconnected from the ground. So we said, what is going on there? We tried to analyze more in detail the situation. And then we moved to the next part. When we moved to the next part, we saw that if we cancel the initial fluctuation part and we use a new 0 point here, that is this date when we disconnected, and we again filtered a little bit data, we obtain this plot. These are quite good plot because these are representing the strains into the pile during construction. That means that the load on top of the piles is increasing, and of course, this means that the graph has to be like this. And again, going into data and looking in detail, we see For example, here at the beginning, this behavior, no change, change, almost stable, change, and so on. And we checked what happened in these 2 days. And this was exactly when the construction reached a certain level and they added a new elevation. This was a precast structure. So they completed one level and they put the new elements on top. When they put the new element on top, we measured this change. And that is very interesting. And we did the same for many other points, many other dates, and we realized that we were really measuring what was going on into the piles during construction. So you see, we started with plots which were very, very bad, terrible. You could have said, no, throw away, stop everything, no reason to go on with that. No. Sometimes happen that, unfortunately, we have to throw away everything. But I always suggest that before throwing away something, please try to understand if measurements are providing some information that we cannot see from the beginning. We have to dig into data, let's say, in order to understand if something is happening and if we are measuring something correct. Okay, so that's a key point. Don't stop at the surface, but go deep into detail. That's the point, the best way to use monitoring data. Here you see an example. When a new elevation has been added, we immediately measure the change into the load. But I repeat what I said a few minutes ago. You see this fluctuation up and down, up and down, up and down. Why? We started from the outside because, as always, we have to look at details, but at the same time, we have to look at the whole structure, the whole situation, the whole environment where we are working. And so we, of course, realized that we were quite close to the sea. So being close to the sea sometimes means that there is an effect due to the tide of the sea. The level of the water is changing, and if you are close to the sea, this means that the water level below your foundation is changing. And changing the level means that let's say, the load is changing into the piles. And if you see, this is the record of the tide. At that time, we have the minimum here, minimum here, minimum here, minimum here. Minimum means, in this case, maximum load, because the load is increasing, going down. So when the tide is low, of course, the load into the pile is increasing. And this justifies this behavior, up and down, up and down. So again, we have to analyze very carefully all what we can say is the context where we are measuring. Because if we just look at the point where we are, probably we miss something. And this is what we got. You see the final global behavior. During the construction, the load was increasing. At the end of the construction, the load was stabilized. That was a quite good result if we compare with the initial plots that I showed. Okay. Using this result, it was possible to define a distribution of load from the maximum value, which is the purple, to the minimum, which is the yellow one, and the distribution was that. And the designer used these results in order to verify their hypothesis. Okay, but that was the analysis of the load transfer from the building into the pile, that means on top of the pile. But there is another level that we have to investigate. It is into the pile. And these are examples of distribution of loads or stresses, as you prefer, into the piles. And there are different situations. Situation like this one on the left, which seems to be quite strange because load cannot increase with depth, or shouldn't increase with depth. This, again, is quite strange. This one is quite correct, but unfortunately, the last section was missing for probably due to the cables. And so again, we have to look into the piles in order to understand how piles behave and why we are measuring this. Are the instruments which are not working properly, or there is a reason for that? We try to analyze in detail, and again, we started from a plot because I think that starting from the plot is always the best way to analyze data, because the plot immediately gives the idea of what is happening. If we read the numbers, it's difficult. It's more difficult to understand what is happening. But of course, here, for example, we see that was one instrument which was not working, another one which was giving very strange result. 14,000 is a number unreasonable, and other which were quite reasonable and similar to each other. So we said, okay, we can use these two and not the other. And by using only these two, we obtain something like this, which is quite reasonable, okay? And we did the same for other piles, obtaining something. And this is an example of application of what is called engineering judgment, because no one of us knows exactly what is happening here. This is an hypothesis. So we say, two instruments are not working, the other two are providing reasonable data, we use that data, okay? But we can consider another point, that in order to move from strain to stresses or to load, we have to apply two parameters, the Young's modulus of the concrete and the cross area of the pile. Which is the percentage of variation of these two parameters? In theory, 0, because we say the pile is 1.2 meter in diameter, so the area is such and such square meter, and the Young's modulus of that concrete is that value. But are we sure about that? And remember that the accuracy or the error or the uncertainty, call as you prefer, of the measurement made by strain gauges is in the range of 0.5 to 2%. How much is the percentage of variation of Young's modulus and cross area? Look at this very simple graph. These are the Nominal area of the pile, diameter of the pile is 1.2 meter. I think you agree with me that the diameter of the pile is not perfectly 1.2 meter from top to bottom. It can be a little bit larger or shorter or smaller. And how much is this variation influencing the area? So if we move from 1.2 meter to 1.25, that means only 5 centimeter extra diameter. 5 centimeter means 2.5 one side, let's say, and 2.1.5 centimeter the other side. 5 centimeter. 5 centimeter in diameter means 10% in area. That means that if at a certain depth, the pile is 1.25 meter in diameter instead of 1.2, the area is 10% larger. 10% larger means that strains are 10% lower. And the contrary, if the diameter is reducing 5 centimeter, the strain will increase 5 centimeter, 10%. So, again, we always say that the instruments are not working properly. They are creating error, they are not accurate enough, they are, but please consider that sometimes the real uncertainty is in the structure, not in the instrument. Same for Young's modulus. Theory said that the Young's modulus is related to the strength and so on. But are we sure that the value is really the one that has been considered by the designer or not? And is it constant from top to bottom? You know better than me how piles are casted at site. Sometimes the injection procedure is stopped for any reason. So material, concrete is maintained inside the mixing machines and so on. So it can change a little bit in case of very high temperature. Unfortunately, people start adding water to concrete in order to maintain it at the acceptable fluidity, and so the modulus can change. Again, how much? 5%, 10%, 15%, I don't know. But probably much more than the 0.5 or 2%, which is the accuracy of the strain measure. So that's an important point. Don't say immediately that the instrument is guilty. We will see a very interesting sentence later on. Sometimes, or many times, it's not the instrument which is guilty. The point is that we don't understand exactly what is going on, or we don't spend enough time to understand what is going on. That means that we don't have to strive for perfection. We have to accept uncertainty and error because they are embedded into the measurement. Don't neglect them, but learn to deal with the fact. That means that the world we are facing at is a world which is affected by error. We have to understand where are these errors, which is the magnitude, how they affect the measurement. Don't say immediately, no, the instruments are not working, throw away all the measurement. But just to remind you this concept, I want to show you this. This is an Italian standard, photon distributor in Italian, related to measures and measurements, terms and definition. Okay. And there is the definition of measure. This is the translation. It says that it is an information consisting of a number, uncertainty, and a measuring unit, which represent a parameter in a specific status of the system. I want to stress your attention to the last part of the sentence, which is to represent a parameter in a specific status of the system. The strain gauges into the piles we have seen are representing what is going on system with all the problems we have seen, considering the tidal effect, considering the area reduction, considering the Young's modulus variation, considering the fluctuation of the signal due to the electrical problem, and so on. They are measuring what is going on in that specific status. So these are the words we have to remember. The number is the value, uncertainty, okay, measuring unit, but the specific status of the system. That's important. Because a strain gauge like the one we have seen before, in a situation like this is a concrete completely damaged by some chemical attack. If they are measuring something wrong, is a problem of the instrument itself or is a problem of the context? The instrument is measuring what he has to measure. And as Alex Feldman said time ago, almost 20 years ago, says result expectation ruins the gauge innocence. The gauge is innocent till proven guilty due to design, misuse, or due to interaction with material surrounding it. Please, I'm not saying that the instruments are always working perfectly. We know that instruments have problems. But before saying they are not working, we have to understand what is going on around. And of course, when you collect data, we have to validate. What does it mean to validate? Means that we have to start from the measured data and to end up with the presented data, what we present. And inside this process of validation, you should include all the analysis we have mentioned before and many, many others, if necessary. So we have to check the operational condition, the working condition, the signal collection, the data reduction, data reduction, to go back, loop of analysis, check and act if. So it's a continuous. We don't have to say that we start from here, this point, we go back, go down to the final point in a straight line. No, we have to stop at every step to verify if everything is correct. Okay, so time is running, but this is another very interesting point to mind. Don't consider that from measured value to presented value, it is just a matter of mathematics. You apply a formula to the value you have collected, you obtain the final result. Yes, it is, theoretically it is, but in between, you have to consider all these steps. And for a good and correct monitoring approach, you have to continuously check this. Not only the first time, but I would say every time you collect one new data, you have to redo this process. Okay? How to present data? Too many times, we as engineers like very much to present big reports with a lot of pages full of numbers. We think that numbers are the God. Yes, they are. But in order to understand, as I said before, we need to, I would say, condensate all the information in the simplest way. And the simplest way to me is the graphical presentation. So instead of presenting pages and pages of data, it's better to present a plot and if possible, a synthesis of this. As our friend Elmo Di Biagio, referring to what Professor Peck always said, Elmo Di Biagio presented in many courses, the best way to present data is a one-page report, a single page A4 report, where you present the basic and fundamental concept that you want to transfer. For example, what you are measuring, what the situation, and the results. With a graph like this, or like this, or like this. Of course, behind this, maybe there are thousands of pages of numbers of data, or as we say today, terabytes of data. But terabytes of data is very difficult to understand if not presented in a form like this. If you present a plot like this, you immediately understand something. You see that here is increasing, then stabilizing, there is a peak, go down, and so on. But immediately transfer you what is going on. And that's the best way to present it. Then behind this, you can present all the numbers. And an example, don't laugh about this. This is me during a check, medical check. And as you know, when you make this medical check, you have pages and pages of something like this. Are you able to understand this? No. First of all, we are not medical doctors. But anyway, even medical doctors, if they have to look at the pages and pages of this, they have to spend time to analyze. So why not use an approach like this? This is exactly the result of the previous plot. I've seen. Sorry, again, it's written in Italian, but this plot you see here is the synthesis of pages and pages of electrocardiogram, as we say. And you see the plot and the key number here. You have a table with the key number where you have minimum, maximum, average, and so on. And you immediately understand what is going on. If you look at pages like this, you don't understand immediately. The point is, imagine that your monitoring system is an early warning system. So you have to decide whether to close, for example, a road because of a landslide is going on, to close a bridge because one pier is moving, to analyze pages and pages of number or plot like this, you are not able to immediately understand what is going on. If you have a synthesis like this, you immediately understand what is going on because you see the maximum values, the variation of the values, and so on. So please, when present data, try to make a synthesis of everything, okay? So let's go to the conclusions. This is a sentence from Peck, again, who said that a good engineer has a feeling of the appropriateness of his solution from the narrowest technical details to the broadest concept level. So again, from the detail, the generalist. His judgment, so we go back to the engineering judgment, tells him if each step is sound and if the whole enterprise is sound. Never concentrate on a single point or just on the broadest view, but continuously move from one to the other. And the example is this. This is the bridge in Baltimore, which collapsed some months ago. I used this before. It's not for it because it collapsed, because it's quite interesting example. If you have to monitor this bridge, you concentrate your attention on a single node to understand what is going on there, or you analyze the whole bridge. The answer is neither the first nor the second answer. We have to continuously move from the joint to the bridge, the complete bridge, up and down, up and down. We have to zoom out and zoom in to verify what does it mean that something is changing in a single point. Which is the effect on the whole structure is something changing in a single point, or what is the effect on a single point when the whole structure is changing its speed. So monitoring data have to be understood because very often it provides data, we provide what we don't know, and allow us to understand the real behavior of what we are monitoring. The point is that provide information about what we don't know. If we were sure about the behavior of something, why monitor? No reason to monitor. We are monitoring because we are not sure, because we don't know what is going on. And I always used to say that if we realize that our knowledge is limited, we don't know exactly what is going on in the structure, we understand the need for measurement and monitoring, and we will enjoy the surprise of obtaining even unexpected data. So when we obtain something unexpected, don't consider it as rubbish or something not correct, but try to understand what does it mean. And the final line, please never give up looking at data, because from something like this, we can obtain something like this. This is useful. This is not useful, but this is useful. This is what we have to do. So thank you very much for your attention. And of course, I'm here. I am available if there are questions. But now I leave the microphone to Ramu and Andrew Ridley.
Thank you, Giorgio, for the wonderful lecture. Certainly, we have some questions posted in the chat box. You want me to read it for you?
Yes, I don't know the plan of Andrew, if he has to leave or can stay, if he prefer to say something
Andrew,
now.
No, I can stay. That's fine.
Okay.
Please
Okay.
carry on with the questions.
Yeah, thank you, Andrew. And Professor Satish Kumar Sharma, he asked the excellent case study. Kindly elaborate correlation between frequency of vibration with the load. What are the assumptions in this correlation?
Okay. As I said, the instrument which have been used in this case were vibrating wire strain gauges. Vibrating wire measure the frequency of vibration of the wire. The frequency of vibration can be correlated to the a strain into the gauge through a formula which I cannot write right now, which uses a factor which is called gauge factor, which is a constant value related to the materials which composes the gauge with the geometry of the gauge. So for moving from frequency to strain, we have to multiply the square of the frequency by this gauge factor and divide the result by 1000. And you correct me if I'm saying something wrong. So is a mathematical correlation which goes through this gauge factor. All the manufacturer provides for their instrument this value of gauge factor, and if you read a frequency, you square this frequency, divide it by 1000, and multiply by the gauge factor, you obtain strain. Strain multiplied by Young's modulus and area provides for loads. I don't know if I answer the question.
Yes, Giorgio, I hope it is answered. And we have got one applaud from Victor Lovedev. Thank you very much for amazing lecture. And yeah, Professor Satish also replied. Thank you for the reply. And any more questions from our participants?
Yes, I'm Dr. Dhawan from Delhi. Can I ask something?
Yes,
Yeah,
sir. Please go ahead.
My voice is audible?
Yes, audible.
Excellent presentation. My question is the data validation. I mean, that is the topic that we started. So, I mean, ultimately, how reliable is the data that will give us all parameters that we need? So, this data validation. And then here the speaker has taken example of a steel bridge. And then the other first example of putting strain gauges in the pile foundation. See, normally the life of such structure, which may be over 100 years, I mean, do we need the placement of such instruments or sensors that we are using in monitoring the structure? That's all.
Yeah, the second part of the question is a very, very good question and a very critical question. Let's start from this. Of course, structures like dams, bridges, or others have a lifespan of decades. Sometimes instruments withstand the conditions where they have to face for decades, and they work for decades. They are still working after decades. I have example. I personally checked of instrument inside them installed more than 40 or 50 years before, and they were still working. But as you correctly said, in my opinion, a good design of monitoring system is the design which take into consideration the possible life of the instrument and the need of replacing, or at least to verify the behavior of the instrument after a certain time. Because there is one point, and I go back to my presentation when I stressed the point of the context where we are operating. Sometimes designers don't have a complete knowledge of the context, or something can change, let me say, around the instrument. So the context is changing, conditions are changing, so the instrument is facing new conditions. Maybe that the new conditions are such that the instrument is not surviving. You have seen the picture of the strain gauges on the concrete completely damaged. And so it is necessary to replace them. Replace instrument is quite, it may be a quite complicated process because, for example, inside a pile, you cannot replace anything. If you want to measure something in the pile, you have to drill inside the pile, drill a borehole to install an instrument. It's quite complicated. But a good design should consider the possibility of replacing or at least to verify. Verify means that if I have, for example, the strain gauge into the pile, and I want to verify after some time if they are working properly, I have to provide for a sort of redundancy of instrument, made better if of different type, which can be considered as more robust than the previous one. So that's a very important point to consider because look, I'm working on a project where the design, the request from the client is for a lifespan of the monitoring system of 110 years. You can imagine that 110 years is a very long period. No one can ensure that. So instead of trying to select or invent an instrument which survives for 110 years, it is better to design a system which consider the possibility to replace instrument, to measure the same parameter from a different point of view, with different type of instrument, and so on. And last point, sorry. Nowadays, technology is changing so fast that in 20, 30, but even probably less, 10, 15 years, the technology we have now will not be more available or will be completely changed. And we will not be able to read the instrument even if they are working because our data acquisition units will not be working anymore. That's another important point to consider. Sorry, saying this, I forgot the first part of the question. Sorry. I don't know if you want to remind your first part of the question, sorry.
Hello, Dr. Escadao, sir, hello.
The first part of the question was the validation of data. How sure finally that the data that we have collected and that analyzed based on which we are getting the results, what is the reliability of data? And data validation.
Data validation is a process which has to be defined according to the project itself. We cannot say that the data validation process is such and such, is a standard process. No, there are some standard steps that we can consider, but I think that the right answer is that for each specific project, you have to elaborate a validation process, considering the conditions, the boundary conditions, considering the effect of activities which are going on at site, considering how you collect data, considering which kind of data process you are applying, and so on. The point is, in my opinion, that you have to focus on the need of validating. Validating means that you have to be sure that the result you provide to your client is correct. I repeat what I said before. Imagine that your system is an early warning system, and you have to decide. You are the one who have to decide if a road has to be closed or a railroad has to be closed and train have to be stopped because something is happening. You must be sure about your data. So your validation process has to be defined according to the specific conditions. But that's a very important part of monitoring activity.
Thank you, Giorgio, for the clarifications asked by participants. And if any participant have further questions, you can free to reach out to Giorgio, and hopefully will respond to you in time. And
Of
also,
course.
with the permission of the TC chair, Andrew Ridley, I would like to summarize Giorgio's lecture series with brief points. So Giorgio has explained about the data importance in the field monitoring by taking Kuwait City, and he has explaining the skin friction files with supporting of instrumentation such as classical strain gauges, automatic data acquisition systems, and also he has narrated for the participants how the disturbances can be measured using these strain gauges. And also he has well pointed out that do not stop at the surface investigation itself. Rather, one must look into or dive into a deeper data analysis. So he has very well explained this parameter through his field evaluated data system. And for the factors affecting that are uncertain to us, he has well explained by taking the tidal effect. And when it comes to the engineering judgment, Giorgio has even explained into deeper that how we have to consider the modulus of elasticity or Young's modulus and the cross-sectional area in assessing the data uncertainties. And so he also reminded of one a point that don't strive for a perfection, but accept the data uncertainties in certain way. So we also quoted some Alex Feldman and from FMGM to 2003 quotes on this data uncertainties. Coming to the data validation, he has also well narrated that how we can rearrange the data and reanalyze if data is inconsistent and find out the appropriate reasons. Okay, he has showed through proper algorithms, and hopefully that the participant will be able to take it such a adaptable algorithm system to analyze the data validation for the purpose. So for coming to the data reporting, so anybody can get the enormous amount of data, and it's very important that understandable ways we have to present it. And Giorgio has explained very well by taking medical cardiograph interpretation, how one generally interpret the data based on the cardiograph variations. So, and also he has said when we are looking at the data top to down and zoom out and zoom in has to be carried out for understanding the various reasons or the disturbances obtained in the data. So very well explained, Giorgio. And the good engineer has a appropriateness for the solution, appropriate solution for the problem. He has also pointed out that, and not least, but finally he said that never give up looking at data. This is very important for field monitoring. And further, we would like to thank TC220 chair for joining us, Andrew Ridley, and the organizing team, Professor Neelima and Nikhil, PhD scholar, and Kunal and his team. And many audience, big thanks for joining us. And Giorgio, we are sure that your lecture will have surely impacted the participants. And your experience is definitely needed in future, even for all the young participants and the researchers and practitioners. Hopefully, they will reach out to you for seeking some solution relevant to the field monitoring. So over to you, George. You want to say a few words, and we can wind up this session. Thank you.
I just want to say thank you very much to you, to Neelima, to all the staff of Indoor IT. And of course, I'm available to answer all the questions that people want to raise to me. You can share my email address to everyone who wants to contact me, and I will be happy to answer to their requests. So nothing else. Thanks again, and I leave the microphone to Andrew.
Thank you. Andrew, please.
Thank you very much, Dr. Rano. Thank you, Giorgio, for an excellent presentation. I look forward to watching it again when we receive the video, because there's a lot of very useful information in there, a lot of good messages. Thank you very much. I have a few notices on behalf of the TC220, so if you allow me to indulge and just share my screen for a second.
Please.
Hopefully you can see my screen there.
Not yet, Andrew. We are seeing your name on the screen as of now.
Okay, let me just see.
Nikhil,
Is
could you
that
please
one?
allow him to access the screen?
Does that one share?
Not yet, not yet.
Not yet.
So he can share from his end actually.
Okay. Okay, sure. There we go.
Yeah. It's
Yeah,
visible.
now.
Now you see it. Thank you. So just a few notices. Let me see if I can get this. The most important one is that the next event for the TC220 is a workshop at the European Conference on Soil Mechanics and Geotechnical Engineering, which happens at the end of next month, at the end of August. We have a whole day workshop dedicated to field monitoring on the Sunday, which is the day before the conference starts, with a lot of interesting discussions around how we can improve the quality of our geotechnical monitoring and how we can use it for the observational method. And the special feature of the day will be a representation by Dr. Alan Marr of the first Dunicliffe Honour Lecture on challenges and opportunities in geotechnical performance monitoring. So please, if you're planning to go to the European conference in Lisbon, please register for the workshop. Come along and we'll have some interesting discussions. A reminder that we have two interactive technical talks that are available through the ISSMG website. One on field monitoring that involves Giorgio and Professor Neelima. So please go to the International Society website and watch those videos. A reminder too that we have two websites available where you'll find information about the work done by TC220. One is part of the International Society website, but we have a dedicated website at fieldmonitoring.org. And there you'll also find links to things like all the previous conferences that have happened, where you can find the papers that have been presented at those conferences. A reminder that all of our news these days comes through the LinkedIn feed. So this is our LinkedIn page on that social media. In the past year, since we started it in August 2023, we've grown by just over 1,000 followers. So if you want to find out what's happening, and we post all the news about talks like today can be found there, please go to the LinkedIn feed and follow us. There are some podcasts available. One on the use of the observational method, Breaking Ground podcast, but there's a wider set of podcasts available by Andre Silva, who I see is in the audience today. So please go to the LinkedIn feed there for Andre, and you will find links to his YouTube channel where you can find some very interesting material, mainly in Portuguese, but I do believe that you can listen to the translation by watching them. So that's an excellent series of podcasts. And finally, just to mention that all of these international lecture series are available on the TC220 YouTube channel. So if you go to YouTube and search for ISSMG TC220, it will take you to the page and you'll be able to listen back to all of the lectures that have been presented. So just to say thank you again to Professor Neelima and Dr. Ramu for giving me the opportunity to highlight our content. Thank you very much.
Thank you, Andrew. I hope many participants will follow up whatever you displayed programming notices. Surely, I also suggest and recommend that please go through TC220 links for your more information and all. And finally, I would like to thank Professor Neelima for giving me this opportunity to facilitate this keynote lecture. And thank you, Giorgio, and thank you, Andre Ridley,
Thank you.
and all others organizers for this wonderful opportunity. And we look forward to seeing you for the next lecture series. Thank you.
Thank you, everybody. Bye.
Yeah. Bye bye. Thank you.